Hi, today's topic is process design and analysis. So, what are processes? Processes are everywhere. They are a series of actions or steps taken in order to achieve a particular end. They are the building blocks of all operations. And the design of these processes will affect the performance of the whole operation. This is a very popular topic in management circles. Process is any part of an organization which takes a set of inputs and transform them into outputs. These outputs can be products or services. The inputs can be any resource. Designing the process means originating and developing a plan for a product, service, or process. So, process design is concerned with conceiving the overall shape and processes and their detailed workings. The first task can be approached by positioning the process. The second task is concerned with the detailed analysis of the process. The second task cannot commence without the successful completion of task 1. So, what is important is to question whether processes match volume variety requirements. Are the selected process layout, process technology, job designs appropriate? Process design is treated in two parts. The first part is positioning, which sets the broad characteristics of the resources in the process. And the second part is the analysis, which refines the details of the design by examining the activities within the process. Let us consider supermarkets. Supermarkets don't just stack their things randomly. They ensure that the revenue per square meter is maximized and cost of operating the store is minimized. How can store layout make you buy more? So, what are the products that are stored in an aisle? They are basic products, vegetables and fruits, items that are fast moving and are easy accessible to the consumer. Now let's take a look at a factory that manufactures chocolates and also welcomes visitors to see the manufacturing process. There are two distinctive different processes in such a manufacturing plant. The first process is the flow of chocolates. Here, liquid chocolate is pumped through pipes to the molding section. Then the molds are moved in lines. The molds are conveyed into a large refrigerator. And after this, it's moved into a section where it shakes out chocolate bars. Now the second flow is the flow of customers who comes to visit the manufacturing plant. There is a single route for all customers. The main exhibition area allows smooth flow of visitors, and timed tickets are issued to ensure constant flow of visitors. So what do these two examples have in common in terms of volume variety spectrum? The volume and variety of demand has a profound effect on the design of the process. Design of the processes in hypermarkets and in small shops are different. What is this volume and variety spectrum? Generally, if a product is of high volume, the variety of the product is considered low. It's very difficult to manage a volume that has high volumes and has high variety as well. The elements of process design are generally strongly influenced by the volume variety requirements placed on the process. The design of a process must be governed by its location on the volume variety spectrum. Most processes should be placed on the diagonal natural line at the product process matrix. Let's try to understand the product process matrix. If the volume of the product is high and the variety of the product is low, such a product becomes a natural candidate for a continuous process. Similarly, if the volume of a product is low and the variety of the product is high, it becomes a candidate for a project process. Based on different mixes between volume and variety, products can be assigned other processes like jobbing, batch, and mass. Jobbing processes are skewed towards project processes because the percentage of variety over volume of the product that uses these processes are high. Similarly, mass processes are skewed towards continuous processes because the percentage of volume over variety of products that use these processes are high. Now, batch processes are generally set in the middle and has characteristics of both project and continuous processes. Process flows in a continuous process, as its name implies, are continuous in nature. These become candidates for automation. Process flows in a project process are intermittent because the activities are specialized. The process tasks in a continuous process are repeated and divided, whereas the tasks in project processes are diverse and extremely complex. So, what are the characteristics of project processes? Products that use project processes are generally one-off products, complex, large-scale, high work content. They're specially made and highly customized. The time scale for making such a product is long. Activities included in a project process may be ill-defined and quite uncertain. Building a ship can be considered as an example of a project process. What are the characteristics of a jobbing process? Very small quantities are manufactured in jobbing processes. Such products has to share the operations resources with other products. These are also specially made and are of high variety and low repetition. The skills required to make such products are usually very broad. Such products are manufactured by skilled jobbers or team of skilled jobbers who have the necessary skills to complete the whole product. Example of such a product could be a garment. What are the characteristics of batch processes? Batch processes usually produce more than one product at a time. These products have high volumes and lower variety than for jobbing. These are standard products having repeating demand, but these processes can also be used to make specials. For batch processes, you need specialized skills. Specialized but narrower skills. Vehicle assembly plants are good examples of batch processing. Let's look at the characteristics of mass processes. These processes are used to manufacture products that have higher volumes than batch. They are standard and they are repeat products. The skills required to manage the manufacturing of these products are low and narrow. There are no setups involved, and the layouts that have been used to manage these processes are cell or product. Example is the manufacture of pizzas. Let's now look at the characteristics of continuous process. These are for extremely high volumes and low variety. Often, these processes are used for a single product. These are all standard products, repeat products. The processes are highly capital intensive and are largely automated. Few changeovers are required. They are difficult and expensive to start and stop. The layouts that use continuous processes are called product layouts. These layouts usually flow along conveyor belts or pipes. Plants that manufacture steel use continuous layouts. We have looked at manufacturing process types. Now let us look at service process types. If the volume of services is high and the variety of the services is low, these services become candidates for mass services process types. Likewise, if the volume of the services is low and the variety of the services is high, these services become candidates for professional services process types. The rest of the services are candidates for service shops process types. So let's look at the characteristics of professional service. These are for high variety and low volume services. These services take a long time to complete. Professional service generally deals with people. Consultancy and advisory services are examples of professional service. Let's look at the characteristics of service shops. The levels of customer contact and customization are between the professional service and the mass service. The service provided by service shops constitute a mixture of front and back office activities. What are the characteristics of mass services? There are many customer transactions but little customization in mass services. Most mass services are equipment based and product oriented. Most of the value addition is done in the back offices and cannot be seen by the customer. All online reservation systems can be considered as mass services. Processes that are far from the diagonal line are either more flexible than seem to be warranted by the actual volume variety position, or they are over standardized and inflexible. Initial position A required to repair and install a wide variety of meters into a wide variety of water systems. This needed a survey stage to assess the nature of the job. The smart meter B, volume variety position change, but process design not change. Unnecessary flexibility and high operating cost. Then the smart meter, smart design C, take the advantage of reducing the variety and complexity, no survey needed, no overqualified staff, and priority based on locations. Now let's look at layout technology and job design. What are layouts? The layout of an operation is concerned with the physical location of its transforming resources. That is deciding where to put the facilities, machines, equipment, and staff in the operation. There are 4 layout types available: fixed position layout, process layout, cell layout, and product layout. So what are process layouts, and are these process layouts appropriate? Layout 2 should reflect volume and variety. Resources in low volume, high variety processes must be arranged to cope with irregular flow. Resources in high volume, low variety processes must be arranged to cope with smooth and regular flow. The diagram shows how different process layouts are appropriate for different volume variety combinations. The fixed layout positions are based around process resources, and the product layout is based around products and services. So what are the characteristics of a fixed position layout? In a fixed position layout, the transformed resource does not move between its transforming resources. Equipment, machinery, plant, and people who do the processing move as necessary because the product or customer is either too large or too delicate. Example, a restaurant. What is a functional layout? In a functional layout, similar activities or resources are located together. Example is a hospital. What are the characteristics of a cell layout? In a cell layout, the materials, information, or customers that are entering the operation are pre-selected. Cell layout is an attempt to bring some order to the complexity of flow. Examples include maternity unit in a hospital, lunch area in a supermarket. In a product layout, the transformed resource flow along a line of processes that has been pre-arranged. Flow is clear, predictable, and can be controlled very easily. Example of a product layout is an assembly line in a vehicle manufacturing plant. This slide shows the similarities between the manufacturing process types, potential layout types, and service process types. It is also important to focus on process technology design. Each processes would require different types of technology. Process technologies are the machines, equipment, and devices that help process transform materials, information, or customers. So process technology is not the same as product technology. process technology in high volume, low variety is relatively automated, large scale and closely coupled compared with the low volume, high variety processes. Let's look at the degree of automation required for each process type. To some extent, all technology needs human intervention. It may be minimal, like in petrochemical refinery, or essential, like in sugaries. Processes that have high variety, low volume does not need high degree of automation. Processes that have low variety, high volume doesn't need high degree of automation in order to be efficient. How big the process scale is. An airline may purchase one or two wide-bodied aircraft or a large number of small ones. Large-scale technologies are suitable usually for high-volume, low-variety products. Small-scale technologies are suitable for usually low-volume, high-variety products. Coupling means linking together of separate activities within process technology to form an interconnected processing system. Tight coupling gives fast process throughput. It is simple and predictable. However, tight coupling is expensive and vulnerable. Tight coupling is only suitable for high volume, low variety. Open and unconstrained coupling is most suitable for high variety, low volume processes. Are job designs appropriate? Job design is how people carry out their tasks. Nature and challenges of job design are governed by the volume variety characteristics of a process. An architect designer will perform a wide range of very different non-predefined tasks, while someone who works in the architect's account office keying in invoice details has a repetitive job and tightly defined. What about division of labor? How should tasks be allocated? Should a single individual perform the whole process, or should separate individuals or teams perform each task? In high volume, low variety processes, dividing the process on different individuals' teams is suitable, while it is the opposite for high variety, low volume processes. To what degree should jobs be defined? Jobs in high variety processes are difficult to define in detail. They require knowledge and experience. Some definitions can be related directly to the outcome. High volume, low variety jobs should be predefined closely with the exact nature of each activity. An individual staff trained to follow a job step by step. Commitment. How should job commitment be encouraged for each processes? In high variety processes, especially those with a high degree of staff discretion, commitment comes from performing the task itself. In low variety processes, the task must be connected to the whole process in order to show the satisfaction to be gained from the process as a whole.